Hi everyone, so for this video I'm going to discuss with you about number system. So let's start with the definition of number system. It's a way of counting things. It's a way of identifying the quantity of something, just like you learn how to count when you were in early childhood or elementary. So it's a set of numbers, or rather a set of symbols used to express quantities as a basis for counting, determining order, comparing amounts, performing calculations, and representing value. So this is really not something new for you. It's just that we will be discussing other forms of number systems rather than your decimal. So the decimal number system is actually very important. Many number systems are in use in digital technology. The most common are, aside from the decimal, are binary, octal, and hexadecimal systems. So, examining some of its characteristics will help us to better understand the other systems. So, later on in this video, I will explain to you how do we represent numbers in these different forms. So, why is it important to learn number systems? First is it's because it's crucial for understanding the processing of digital system. So your digital system, or rather than, or in other words, your computer, takes binary, octal, hexadecimal number as input and processes it and generates the output. So encrypting important data is also another reason for learning number system. It's by converting into another number system to avoid hacking and misuse of data. So for the decimal system, so I mentioned that we will be discussing or learning aside from binary, decimal, hexadecimal, and octal. So let's start with decimal system. The decimal system is composed of 10 numerals or symbols. So these are 0, 1, 2, 3, up to 9. So that is equivalent to 10 symbols. So using these symbols as digits of a number, we can express any quantity. And you have to remember that using the decimal system, the base is 10. So it's also called the base 10 system because it has 10 digits. So when we represent a number as a decimal, we have to use a base of 10. So 89 is written as 89 with a base of 10. 735 is written as 735 with a base of 10. Alright, so let's move on to binary. So binary is contrary to the decimal number. It only has two symbols or possible digit or values, and that could only be either 0 or 1. So since there are only two forms, the base 2 system is used to represent any quantity that can be represented in decimal or other number system. So for instance, so 101 is written as 101 with a base of 2. 11001 is written as 11001 with a base of 2. Octal, on the other hand, has digits 0 through 7. So any other digit that is not within the range 0 to 7 is considered an invalid octal number. So for instance, if you say that it's an octal number but 8 is there or 9 is there, then that is an invalid number. So octal number has a base of 8. Okay, you have to remember that, and simply because it has 8 forms or 8 valid digits. So for instance, if you say 146 in octal form is written as 146 with a base of 8. So you have to be very clear on that because it could be a decimal number or it could be an octal number. So if you see 8, then that means it's an octal number. So 715 is written as 715 with a base of 8. Now, if you say 182, and if you claim that it is an octal number, that is an invalid octal number because 8 is not part of the digits that's valid within the octal number system. Okay, now let's move on to the last one, which is hexadecimal. So with the hexadecimal number system, you have 16 digits. That's 0 up to 9, so that's already 10 digits with letters A, B, C, D, E, F. Now these letters A, B, C, D, E, F actually implies 10, 11, 12, 13, 14, and 15. So in essence, because we start at 0, that is equivalent to 16 digits. So hence, when you represent hexadecimal numbers, it will also have a base of 16. So prefix hex means 6 and decimal implies 10. So therefore, hexa plus decimal or 6 plus 10 is equivalent to 16. So for instance, if you say 1, 12, and 16 in hexadecimal form, this is written in 1, C, 6. Now, where did we get C? Because 10 is equivalent to A, 11 is B, 12 is C. And so therefore, 1, 12, 6 is written as 1C16, 1C6 with a base of 16. Now, on the other hand, if you say 13, 5 in hexadecimal form, 13 should be written as letter D. So remember, A is 10, B is 11, C is 12, and then D is 13. So D, 5 with a base of 16 is a valid hexadecimal number representation. Now in the next videos, I will be sharing with you how to convert any of these numbers, decimal, octal, and hexadecimal, to binary. We will also learn how to convert any number to decimal. That means converting binary to decimal, octal to decimal, and hexadecimal to decimal. Also any number to octal, meaning binary to octal, decimal to octal, and hexadecimal to octal. And last but not least, any number to hexadecimal. That means we will learn how to convert binary to hexa, decimal to hexadecimal, and octal to hexadecimal. So in summary, in this video we have learned to define what is a number system, why is it important. We also learned the other forms of number systems that are being used and how they are represented. So binary with a base of 2, decimal with a base of 10, hexadecimal with a base of 16, and octal with a base of 8. And of course, we also have set your expectations on what conversions we will be learning in this lesson. Thank you very much.